Hi, this is Calandra, and welcome to week 4 of Calandra and Nino's College Algebra Cohort. Today we're going to be looking at how you find the inverse of a function. But before we get into that, let's recall what you've learned before, that a function is a rule in which every input has exactly one output. It can be determined if a graph represents a function by using the vertical line test. So to illustrate this using the graphs below, I know that every input, and remember the input are the x values, has exactly one output. Remember the output are the y values. So if I draw a vertical line through a graph and it hits it in one point, that means that for whatever x value this is, there's only one corresponding y value to it. So notice that any vertical line that I draw for my first graph crosses only one time. Okay, so every vertical line hits graph at most one time. And therefore, that means the graph represents a function. Now, if we look at our second graph, I see that if I draw a vertical line, it's possible to draw one that intersects the graph in more than one point. So notice for this single x value, there are two y values that are associated with it, and that contradicts the definition of a function. So since it intersects twice, this is not a function. Okay, and then for the last graph, any vertical line we draw will cross this function only one time. Therefore, I know that this graph does represent a function. A function is said to be one-to-one if every input has only one output, because we know that's the definition of function, and every output has only one input. That's what will make the function one-to-one. So every y goes with only one x value. It can be determined if the graph of a function, so to determine if the graph is a function, we know that we'll be using the vertical line test. So assuming that our graph is a function, we can determine if it's one-to-one by using the horizontal line test. Okay, so if we look at the first graph, we already know that it's a function because we saw earlier that it passed the vertical line test. However, when I draw a horizontal line, I see that it crosses more than once. So we have a y value that goes with two different x values. So that tells us that this is not one-to-one. Okay, looking at the second graph, we already know that it's not a function, therefore it's not one-to-one. Okay, well, if I look at the last graph, I can draw a vertical line that crosses more than once. So this graph is not a function, therefore it cannot be a one-to-one function. Okay, next, example. Determine which of the following functions are one-to-one. Okay, so that means we want to see if they pass the horizontal line test since we're given that they're functions. So we're going to pull from what you learned in a previous lesson. When we look at f of x equals negative 3x squared, okay, so let me write it like this. So we have negative 3x to the second power. Hopefully you remember that the graph of x squared is a parabola. The negative is going to make it open downward, and when you multiply by 3, it just makes it skinnier. So the graph of this is going to look something like that. So when we draw our horizontal line, it crosses more than one time, so that tells us that it is not one-to-one. Okay, going on to the graph of b. Okay, we have the absolute value. So if you think back to the basic functions, the absolute value of x is a v with the point at the origin. When we subtract 3, that's going to move the graph to the right 3 units, and we still have the same shape. Now, for this one though, we're told that we're looking at this graph where x is greater than 3. So that means we're only interested in this portion of the graph to the right. Okay, we're not interested at 3, so there's really an open circle there, and we can delete the other portion of the graph. So based on that restriction that we're given, if I draw any horizontal line, it's only going to cross one time. So this is one-to-one. Okay, going on to part C. Notice that that's in the form y equals mx plus b. And hopefully you remember anything that can be written in that form is going to be a straight line. So even if we didn't plot exactly where the graph is going to be, if I know the graph is going to be a straight line, the slope is positive, so I know it's going to be going up. When I draw a horizontal line, it's only going to cross one time, so this must be a one-to-one function.